Hello, everyone. I'm Travis Wright, a partner engineering manager in the Azure Data Engineering team. In this session, I am joined by a few colleagues to show you the latest tech we built to enable you to develop and manage apps and data in hybrid and multi-cloud. We have exciting product news and in-depth technical demos on building cloud-native apps for Kubernetes, data, and machine learning, all coming together. So let's jump right in. We've talked about digital transformations for some time now. At the heart of this transformation is the digitization of data. If there's one thing the past 2 years have taught us, it is that data is truly the strategic asset for all types of organizations today. During this time of uncertainty, a new level of data agility is required to deal with sudden changes in our world. Those who have embraced their data as a strategic asset have fared better. They have established the culture and capabilities needed to be more agile, able to anticipate and predict disruptions, and pivot as needed to better serve their customers. Doing this isn't easy, though, given the realities of data today. The volume, variety, and velocity of data are all accelerating dramatically. IDC predicts that by 2025, the world's data will climb to 175 zettabytes. To put that in perspective, if you were to store that data in a stack of Blu-ray discs, you'd be able to go to the moon and back 23 times. For application developers, the explosion of data also brings in questions about what data sovereignty rules are you subject to? Do company compliance rules or government regulations require data to stay on premises or within country borders? What about data access latency? Will your apps require real-time compute and data processing? Can you store your data on the cloud and access it on the edge reliably? How will you architect for resiliency in your application modernization journey? Are you going to get into hybrid, co-location, multi-cloud, and the edge? Well, Azure makes it easy to develop modern apps using cloud-native architectures with microservices, managed databases, DevOps support, and enterprise-grade security. Azure provides unmatched security capabilities like Microsoft Defender and a policy-driven approach to governance using Azure Policy and Azure Role-Based Access Control. It also enables GitOps-driven deployments and at-scale management, faster CI/CD and time to market, and agile application lifecycle management. Plus, it handles all of your data and AI pipelines with fully managed services. You get the latest features and built-in capabilities like high availability and disaster recovery, so you can drive down IT overhead significantly. With Azure Arc, we are able to bring those Azure innovations and cloud-native benefits to customers who must operate and run workloads that span on-premises, Azure, other public clouds, and edge sites like retail stores or manufacturing facilities. Imagine how that would simplify your app and data management, achieve consistency and efficiency so you can develop your app once and operate anywhere with the data and AI capabilities to unlock insights in real time. We are seeing customers adopting Azure Arc across a wide spectrum of scenarios for their app and data management. Some customers want to modernize existing applications in place in their own data centers, while others want to build new cloud-native applications that extend or run them outside the cloud. US plumbing supply giant Ferguson is using Azure Arc to extend Azure data services to its on-premises data centers. Specifically, they migrated from SQL Server to Azure Arc-enabled SQL Managed Instance, so they are always on the latest version of Azure SQL, just like inside of Azure. They never have to worry about when a given SQL Server version might go out of support again. Royal Bank of Canada is the largest bank in Canada, and they also have the largest deployment of SQL Server in the country. They recently adopted Azure Arc-enabled SQL Managed Instance to get database as a service benefits like cloud billing and built-in high availability for their on-premises databases, supporting the next generation of financial services apps for their customers. We also have KPMG, a global professional services firm with thousands of clients across the globe, each with their own data governance needs. They use Azure Arc to manage, track, and govern databases in their own data centers, and in their customers' data centers, and in public clouds around the world in a consistent way and from a single point of control, Azure. Because of the services they provide, which includes auditing, tax, and accounting, they need to remain compliant in whatever country they operate in. And the hybrid solution from Azure Arc helps them flexibly deliver their services wherever customers need them. Koç Systems is the systems integrator arm of the Koç Holdings conglomerate in Turkey. Turkish companies must now comply with data sovereignty laws that require PII data of Turkish citizens to be stored in-country. Koç Systems uses Azure Arc to deliver the power of Azure app and data services hosted in data centers in Turkey to meet these requirements and yet realize all the benefits of Azure data services. And lastly, we have SKF, a Swedish manufacturer that recently underwent a complete transformation to create a digital manufacturing factory using Azure Arc. They embraced the full Azure hybrid solution by running Arc-enabled SQL Managed Instance on top of Azure Kubernetes service on Azure Stack HCI to deliver a cloud-orchestrated, locally executed operations model in their 97 factories around the globe. This model delivered considerable efficiencies and cost savings for SKF, enabling data-driven manufacturing at the edge. So let's unpack the capabilities of Azure Arc-enabled data services that have powered these customers' digital transformations. Arc-enabled data services includes two services, SQL Managed Instance and PostgreSQL, originating from the PaaS database as a service offerings in Azure that can now run on any Kubernetes cluster in customers' own data centers, in edge site locations, and even in other public clouds. These next-gen data services provide automated, no downtime, monthly updates, so you're always getting the latest features and security updates. There's no more tedious manual update overhead or end-of-support lifecycle situations. It is database as a service, fully automating routine database administrator tasks with self-service provisioning, built-in automatic high availability, disaster recovery, backup, and point-in-time restore. It optimizes data workload performance and reduces costs by bringing cloud elasticity on premises, using only the resources needed by scaling up or down without application downtime. You pay just for what you use instead of buying licenses for your peak expected usage. The consistent management experiences simplify DevOps by drastically reducing overhead. You can deploy a 3-replica SQL Managed Instance with full HA in 2 minutes via a single click or a command line instead of hours. Or you can get centralized visibility into query performance, storage capacity, and error logs using dashboards directly from the built-in monitoring. All these capabilities can run in any environment regardless of the connectivity to Azure. If you can be fully connected to Azure, the user experience is more rich in real time, but it's not required. You can run Arc-enabled data services without a connection to Azure. We understand that not all customers can connect to Azure all the time. Your environment may not have continuous connectivity, such as a cruise ship. Your environment may have a slow connection to Azure, such as over a 3G network. Your organization may have security or data governance policies preventing outbound connections to the cloud. The way we architect Arc-enabled data services to meet these requirements is to provide a local Azure Arc data controller to operate all the needed management capabilities even without a connection to Azure. Let's look at how Arc-enabled data services is deployed. First, deploy your choice of any CNCF certified Kubernetes distribution or cloud service on the infrastructure of your choice. Then deploy the Arc-enabled data controller as a set of pods on the Kubernetes cluster. These pods provide all the management capabilities right there inside of your Kubernetes cluster. Now you're ready to deploy and manage Azure Arc-enabled database instances like SQL Managed Instance or PostgreSQL using the Azure Portal, Azure Data Studio, Azure CLI, or even Kubernetes native tools like kubectl, Argo, or Flux. In the direct connected mode, Azure Arc agents continuously send data to Azure, and you can operate all of your databases across all your environments from a single point of control from anywhere in the world via the Azure Portal, the Azure ARM API, or the Azure CLI. In the indirect connected mode, you can still manage everything locally using Azure Data Studio, the Azure CLI, or Kubernetes native tools, and just periodically export and upload the small set of necessary billing data to Azure. From there, you can connect to a database instance using standard application data access libraries or tools, just like you always do. At the end of the day, it is your data and your app, and we want to give you the flexibility to have a greater or lesser degree of connectivity to Azure depending on your requirements. The choice is yours. Last summer, we announced general availability of Arc-enabled SQL Managed Instance general purpose. Today, I'm thrilled to announce the general availability of Azure Arc-enabled SQL Managed Instance Business Critical service that many customers have been waiting for. The Business Critical tier is really geared towards the most demanding mission-critical workloads with all the proven capabilities from the SQL Server engine most of you have trusted for over decades. It comes with full feature parity with SQL Server Enterprise Edition, which runs OLTP and HTAP with record-setting performance, advanced high availability, and top-rated security. It also meets the most demanding business continuity requirements using always-on availability groups, so your app will have close to zero downtime in case of an automated failover. You may choose to fail over to another instance within the same Kubernetes cluster, or in a different cluster, which could even be in a different data center, or the public cloud, effectively providing cloud-level redundancy. To ensure this DR solution is cost-effective, we also provide a free passive instance to run in your disaster recovery site. As you'll see in a demo with Jess in a few minutes, the architecture of Business Critical using multiple replicas, each with their own copy of the data, allows for fully automated rolling upgrades for near zero downtime. There's no limit on CPU and memory configuration, and you can choose whatever combination of memory and CPU that best suits your workload. To further maximize the performance, we provide one free read scale replica for you to offload any read-heavy workloads too. Last but not least, all dev test instances are free, making it simple for you to try a proof of concept or run development environments and CI test runs on either general purpose or business critical. Speaking of performance, let's take a look at a set of OLTP benchmarks that were conducted by our partner team at Dell. Arc-enabled SQL Managed Instance, which runs on Linux containers powered by Dell PowerEdge Compute and PowerStore storage, is proven to provide the same performance as SQL Server on Windows Server so you can run your workloads with confidence. The Dell PowerEdge 15G servers with the latest Intel processors provide plenty of compute for any Arc SQL Managed Instance deployment, and PowerStore meets the shared storage requirements for backups from one single appliance. Arc-enabled SQL Managed Instance Business Critical runs 15% faster on identical TPCE-like workloads on Dell PowerEdge and PowerStore hardware compared to SQL Server on Windows running on VMware on the same hardware. Not only that, the speed of provisioning and deprovisioning will massively speed up your CI test runs. SQL instances can now be deployed very easily via automation and be available in 60 seconds. Moreover, Business Critical cuts multi-replica HA deployment time from hours or days to 2 minutes with a single command. Grafana dashboards allow end-to-end insights from SQL MI to cluster to Dell PowerStore storage, allowing more performance insights than ever before. The results are really exciting. Let's take a look. All right, so today we're joined by Robert Sonders from Dell. Robert, thanks for joining us today.
Appreciate it. Thank you.
Excited to dive in on the details of this testing that you did. So tell us a little bit more about the test environment, maybe starting with the hardware and what you guys had there.
Well, our teams at Dell with the PowerStore teams reached out to me because I've been working a lot, well, even with your teams, with Azure Arc and all things kind of hybrid and on-prem. So we wanted to do some testing with PowerEdge and PowerStore. So the PowerStore product guys reached out to Intel, and they provided us some Intel Xeon Gold boxes, really 6330s, I think they were.
Oh, nice.
So really great environment to do some really good performance testing, kind of just a level set to say we're using the best of the best from Intel.
Right, that's awesome.
Yep.
So let's make sure people kind of understand what we were comparing here, like the A versus the B, right? With A, we had SQL Server running on Windows Server on a VM on vSphere, which is a super common deployment topology that lots and lots of customers use in production, right?
Correct.
Probably the most common, right? And then we had Arc-enabled SQL Managed Instance running on a Linux container on Kubernetes on bare metal hardware, right? So that's what we were comparing. So tell us a little bit more about that.
Well, we talked, the product teams and I, we talked about what would kind of be that good benchmark, maybe removing some of the layers. So let's do bare metal Kubernetes, deploy the SQL Azure Arc, the business critical managed instance right there with a 3-node always-on group, and then we compared that to the same thing in Windows, 3-node, or 3, I guess, virtual machine always-on group.
Right.
And we compared those two, and what we found, doing the same workload on the same, being against that same Intel box, we found about 15% better performance running on that Kubernetes bare node with the Azure Arc SQL Managed Instance. That was pretty cool.
Yeah, that is awesome. And I guess that's sort of expected because you're running on bare metal versus in a VM. And there's probably some trade-offs here, right? Like historically, I think people would think of running on bare metal as you kind of lose the advantage of having a virtual machine fabric in there and the ability to do things like vMotion and maybe get better availability or isolation because you have those virtual machines. So there's kind of these trade-offs, right? Like, what are your thoughts about that?
Well, I mean, it's a business decision, but it's kind of where things are going now. That control plane is kind of changing. Where is it Kubernetes now? Do you need a hypervisor? Maybe yes, maybe no. And Microsoft is also pushing that HA kind of up the stack with the business critical always on groups. We can spread that out now across fault domains potentially. So that's all productionalized and ready to go. So why not do that in an environment and remove maybe not really the complexity, but maybe, again, that control plane is probably moving towards Kubernetes.
Right. So I guess what you're saying is that if I run on Kubernetes on bare metal, not really giving up anything, I still get that high availability because the orchestration of that has moved up to the Kubernetes and that integration that we've done between Kubernetes and always on availability groups to monitor for the availability of the replicas, automatically fail over, bring new replicas back online. And so we can even do that across fault domains, like you said. And so there's really no compromise, right? I can get the best performance and get that high availability.
Not to mention we're deploying it in just a few minutes, right?
Right.
And try doing that with 3 VMs, with the SQL Server VMs. That could take some time.
Wire together all that availability group, the Windows failover cluster,
That's
all
right.
of that, right? Yeah, that's definitely a real challenge.
And that's
to
all
automate.
orchestrated as just a couple lines of Azure CLI code. It's pretty elegant.
Yeah, nice. Okay. So let's talk a little bit more about the storage then, right? Because databases love storage. We need fast and reliable storage, right, for our databases. So tell us a little bit more about PowerStore and kind of how that powers the data durability here.
So a requirement for the SQL MI, the managed instance, is one of the storage classes, storage class backup, needs to be read-write many. So when we have a failover, the new primary in an always-on group can now also write to that same backup storage. So with PowerStore, we have the opportunity for file and block all in the same appliance. That's really nice.
Right.
That's a complete solution.
So I guess the way to kind of think about this architecturally is when you have a business critical instance of SQL, you have multiple replicas. Each replica has its own copy of the transaction and data files. Full copy. It's written to persistent volumes on physical disks. Like this is not any different than how you'd normally deploy SQL in terms of data durability
Correct.
and replicated data sets, right? And then with this read-write many persistent volume, you have this shared persistent volume that each of the replicas can read to and write from in the event of a failover. So you're just doing backups once.
Correct.
And just using that shared volume.
And with persistent volume claims, yes, there is, why would I put my database in an ephemeral container? Well, it's not. With the stateful sets that are deployed with the MI, everything is persistent. Right. It's there on disk. So we're not losing any data.
Yeah, so even though it's in a container, it's not like we're at risk of losing our data or something, right?
That's right.
Yeah, no, it makes sense. So, okay, so it's funny. We met here just across the street, maybe 3 or 4 years ago for the first time, and I remember sitting in one of our team rooms there, and we were going crazy on the whiteboard talking about SQL Server on Linux and containers and running on Kubernetes, and that was really a fun session. I remember that. But you've been working with SQL Server for a really long time, since SQL Server 6.5, you were telling me. So for somebody that has that perspective of working with SQL Server for such a long time, what do you think will be appealing to the DBAs and developers out there about Arc SQL Managed Instance?
Ease of use, scripting, right? You mentioned 6.5, that's before GUI.
Right.
So we were scripting, but we were, storing our code, and now we're storing our code in GitHub or wherever, we're sharing it around. It's so repeatable to deploy an Azure Arc Managed Instance. Again, those just a few lines of CLI code to run it and deploy it. But back when we met, I remember we talked about SQL on Linux in a container, and then we mentioned Kubernetes that was coming also. I'm like, as a Windows guy and SQL Server guy for many, many years, I thought I need to learn all of this and learn it really, really well.
Right.
So because that's not going away. As you know, more and more services are being deployed to land on that type of architecture. So it is where everybody needs to be with their SQL Server deployments. It's much cleaner and it's easier.
Right.
It just is.
faster, right? Because it's just, you can get an always on availability group up in a couple of minutes,
Correct.
right? And it's repeatable because it's scriptable. But I think the key thing that you and I were talking about earlier today is really that nobody needs to change their tool set completely, right? Like, yeah, there's some new concepts to learn with Kubernetes and containers, and maybe some people are going to learn Linux that have been historically Windows, but things like SQL Server Management Studio, Azure Data Studio, SQL CMD, all these tools just work.
It just
right?
work.
And the application developers, they just use the same data access libraries and endpoint connections.
Yes, I mean, some of our testing all orchestrated with things like tried and true SQL command, right?
Right.
It all just works, pointing to Linux and SQL Server MI, it just works. Management Studio you mentioned, it's the same thing.
Yeah, nice. Nice. Okay. So a few new things to learn, but you can always use the things that you're familiar with too.
That's right. That's right.
All right. Well, hey, thanks, Robert, for joining us today. And we'll look forward to seeing what else comes up next.
Yeah, it's exciting times.
All right. Thanks.
Yeah, thanks.
We are working on obtaining the official TPC audit with a white paper on all the cool things such as linear scaling that you want to know. Azure Arc-enabled SQL Managed Instance provides you with a cloud billing model for better cost efficiency. We provide two options, depending on whether you want a CapEx or an OpEx purchase. First, the consumption-based billing model, or pay-as-you-go and just-for-what-you-use model, allows you to scale up and down over time and pay just for what you need and use. For example, you could scale up a business application during business hours and scale it down overnight. Meanwhile, you could scale up an analytics database to do end-of-month batch processing and scale it back down when you're done. Remember, this scaling can be fully automated and happens with near zero downtime. Second, the capacity-based billing option with 1- and 3-year reserved instances gives you cost savings for a longer-term commitment for workloads with predictable use patterns. Additionally, for SQL Server customers with software assurance, we will provide the same set of Azure Hybrid benefits so you can have significant savings from reusing your existing SQL Server licenses. Now, once you have all your operational databases running consistently across environments, let's talk about how we enable a full machine learning pipeline to discover the valuable insights from your data. With Azure Arc-enabled machine learning, you get full Azure Machine Learning Services capabilities to build, train, validate, and deploy models in your data center, edge site, or even other clouds. Here are some fully automated ML pipeline use patterns we've been talking to our customers about. First, you could train the model in the cloud to leverage the cloud infrastructure, compute elasticity, and massive data storage capacity, and then deploy the model on premises to meet security and inference latency requirements. Alternatively, you could train the model on premises for data privacy and data residency requirements, and then deploy the model in the cloud for global access to the model from your applications. Or lastly, you could train and deploy models on premises for full confidential ML, keeping both data and the model on premises. We have heard from many customers who have multiple edge locations like retail stores and branch offices that what they need is a smaller footprint for their local compute resources, including data services. With the Azure Stack HCI single node, customers can now benefit from all the hybrid capabilities offered by Azure Stack HCI, but in a much smaller form factor. In the case of retail companies with hundreds or thousands of stores, for example, the one-node solution can greatly reduce hardware costs while maintaining the capabilities of managing the compute resources they need in the stores from the Azure portal. I am truly energized with all these announcements, and I certainly hope you are excited as well. As I shared earlier, Azure Arc is the technology framework that enables us to bring Azure services anywhere you need them. Let's dive into learning a bit about how Arc simplifies your app and data deployments across hybrid and multi-cloud environments. To tell you more and kick off the in-depth technical demos, here's my friend Jason.
Thanks, Travis. My name is Jason Hansen, and I'm a program manager working on Azure Arc. Now, as Travis shared earlier, we know that many of you want to build applications in a hybrid or edge environment with application patterns and tooling that is cloud first. With Azure Arc and Kubernetes, our goal is to ensure that we don't get in the way of the bet you are making on the Kubernetes ecosystem and its APIs. Now, Azure Arc enables developers to use familiar tools like GitHub and Visual Studio Code to build and deploy their applications to Kubernetes clusters anywhere. Now, Azure Arc includes GitOps capabilities, so developers may centrally declare, deploy, and enforce a common set of configurations and apps on Kubernetes clusters, no matter where they are running. Now, when developers check in new features or change a configuration, those updates are automatically deployed. Even better, developers and operations teams can use Azure Policy to enforce and audit all your GitOps configurations. Now, Azure Arc is about choice too. GitOps not only works with AKS, but you also have the flexibility to use your choice of CNCF conformant Kubernetes distros, like Red Hat OpenShift, Rancher, and many more. Simply Arc-enable your clusters and you are ready to go. Now, finally, Azure Arc also makes it easy to connect to your clusters, no matter where they are. Using your Azure credentials and Azure role-based access control means you can request a secure connection and use any native Kubernetes tools. Now, this is great for interactive debugging, troubleshooting, or integrating with your CI/CD pipeline. Now, GitOps is great, and we'll talk about it in more detail in a minute. But Azure Arc also gives developers tremendous flexibility in how you write your apps. You can bring the Azure services you are using today and love, including Azure SQL, Azure PostgreSQL, and Azure ML services wherever you need them. Now, whether it's new applications or one you've already written, you could easily deploy, secure, and monitor all your apps with Azure Arc-enabled Kubernetes, GitOps, and Azure Monitor. Now, the important thing to note is that the way you deploy does not change. You can continue to use your existing tools and practices and benefit from a seamless, consistent experience. Now, let's quickly recap what Arc-enabled Kubernetes gives you. Now, for customers new to Kubernetes, we provide an end-to-end Microsoft solution with AKS on Azure Stack HCI and on Windows Server, which is easy to deploy and keep up to date. We also understand that you may have existing Kubernetes clusters. You can connect these to Azure Arc 2 and ensure a single pane of glass management for your entire portfolio. Now, whether you are using AKS or bringing your own infrastructure, developers can deploy apps and cluster configurations using GitOps. And finally, you can ensure security, compliance, and observability for all of these clusters using integrated Azure services, such as Microsoft Defender for Cloud, Microsoft Sentinel, Azure Policy, and Azure Monitor. Now, let's go back and talk a little bit about deploying applications. Now, I've mentioned GitOps a few times, and we've got a cool demo in just a moment. But before we dig in with my friend Lior, let's unpack GitOps for those who may not be familiar with the technique. So with GitOps, Git will act as the single source of truth for our applications. Any changes we need for our app, create, an update, or delete, it happens in our Git repo. Last, all changes are observable. We've got a commit history and artifacts like pull requests. Now, this means that all our resources will be described declaratively using Kubernetes manifests or Helm charts. The repository supports immutability, versioning, and history. And next, all approved changes are expected to be applied automatically. Last but not least, reconcilers running in our clusters are responsible for deploying and maintaining the resources. Now, if the cluster state drifts due to administrator action, the agents are responsible for automatically driving the cluster back to the desired state. So, what does this workflow look like for our developers end to end? First, let's start with a Kubernetes cluster that has been Azure Arc-enabled and is connected to Azure for management. A user with the right permissions creates a GitOps configuration for the cluster using Azure APIs. Behind the scenes, the Azure Arc deploys and configures Flux, which starts listening to the configured repository which holds the developer's application. The Flux operator compares the local cluster state to the desired state expressed in the repository, and if anything is out of sync, Flux will make the necessary changes. Because this is the first time Flux is run on the cluster, all the application components are deployed. Now, let's say a developer needs to push a critical update. The developer updates their application and creates a pull request. As soon as the pull request is merged, Flux observes the updated state and patches the difference. The application is transparently rolled out across all my infrastructure. This is great. GitOps helped us deploy applications. GitOps helped us keep our clusters from drifting away from our desired state. GitOps helped our developers and operations teams stay on the same page, and all our production changes are tracked in Git commits and pull requests. Even better, we can do this with 1, 10, or hundreds of Kubernetes clusters. So let's see this in action. Lior from the Azure Arc team is going to join us, and he has a demo ready. Lior, take it away.
Thanks, Jason. Hey everyone, hope you're having a great build so far. Contoso Books operates bookstores across the globe. The company has been going through a major digital transformation and is updating applications and infrastructure across their entire footprint, including their stores. Many of the regions they operate, especially in European countries, have strict regulatory and data privacy rules, which means the customer data cannot leave the region. Contoso Books has a mix of applications. Some are internal workforce management apps that can be hosted in Azure, but it's critical to keep customer data on premises. Contoso developers want the freedom to choose the data services and tools available to build these applications while ensuring they comply with regulations. To run their apps and manage data, Contoso Books has chosen various types of Kubernetes distributions, each with its own requirements and footprint. Let's take a look at the demo I recorded and see how these services come together. As you can see, Contoso has 4 Azure Arc-enabled Kubernetes clusters, using 3 different Kubernetes distributions: Cluster API, Rancher K3s, and Azure Kubernetes Service, AKS, which is provisioned on Azure Stack HCI. These clusters are running in 4 stores in 3 different countries. Regardless of where these clusters are running, Azure and Azure Arc makes it easy to manage centrally and consistently. Let's take a look at Cluster API deployment. As you can see, the Azure Arc agent shows important resource metadata like the backend infrastructure and the Kubernetes version. In order to take advantage of the Azure Arc extensibility model, Contoso installed various cluster extensions on all 3 clusters. These extensions will let them implement Azure services and capabilities such as Azure Policy, Microsoft Defender for Cloud, Azure Key Vault, Open Service Mesh, GitOps, and more. Looking at the Rancher K3s cluster, also onboarded to Azure Arc, we can see different metadata information and also fewer extensions, highlighting the flexibility offered with Azure Arc-enabled Kubernetes. Welcome back. One of the primary goals for Azure Arc is to meet customers where they are with their existing investments. Whether your applications are running on a server or a VM-based infrastructure, or you already have Kubernetes clusters, Azure Arc can help manage across your environment. But what about your existing container-based applications and solutions you are using from the Kubernetes ecosystem? How do you know that your clusters are configured according to your needs? How do you know that the application and configuration haven't drifted from your desired state? How do you keep up with the ever-increasing count of clusters, locations, and cloud environments at scale? Azure Arc helps here too, with native integration for GitOps and a dedicated Azure Arc-enabled Kubernetes cluster extension based on the Flux open source project. Using a GitOps approach means Contoso developers define their apps in any configuration in a set of files. Check those files into a Git repository and bind that repository to 1, 10, or even hundreds of clusters. Any Kubernetes manifest or Helm chart is fair game for GitOps. With everything in source control, everyone stays on the same page. Adding, updating, or removing configuration is reviewed and approved with an audit trail, discussion, and even test results. Let's take a closer look at some of the cluster extensions installed on the cluster. Contoso Books has defined a baseline for their bookstore microservices application configuration and are planning to perform a blue-green deployment on all their Azure Arc-enabled Kubernetes clusters so they can test the new version for the application front-end service. The service is designed to count how many books Contoso sold and show this information on their company internal website. Each time a book is sold, the website will capture the transaction and will update the counter. Let's take a closer look on the cluster extensions. The first extension to pay attention to is the Flux extension, allowing the implementation of GitOps configuration, so the bookstore application will always be up to date based on its settings in Contoso's GitHub repository for the application. We also see that the Open Service Mesh cluster extension, OSM, is installed as well. That will allow Contoso to control traffic routing to the application in a governed manner. These extensions are the foundations for Contoso's Azure Arc-enabled Kubernetes application deployment. Next, we will review the GitOps config and its settings. The first config to pay attention to is the config bookstore, which will initiate the deployment of the application based on the targeted GitHub repository. This repository is where the application Kubernetes manifest files are located. Let's look at the OSM config as well. The config will allow Contoso developer to test the traffic routing and the web request, which will then translate to the number of sold books and split the traffic between version 1 and version 2 of the bookstore application. This is possible since the config is also listening to the same GitHub repository, which holds the Open Service Mesh routing Kubernetes manifest file we will explore here in a moment. Let's review the current application deployment. We can see that all the traffic for the number of books sold is routed to use version 1 of the bookstore application, with no traffic going towards version 2. The GitHub repository we are seeing here is the same one we saw a moment ago, in both the Flux and the OSM cluster extension settings. As you can see, the current traffic split is configured in a way that version 1 of the application receives 100% of the web request. Before initiating the blue-green process workflow, let's run a simple kubectl command to monitor the deployment and its Kubernetes pods. We will come back to the repository and apply a change to the traffic split policy by updating the YAML file to 25% of web requests that will be routed to use version 2 of the application. The Azure Arc-enabled Kubernetes GitOps config that uses Open Service Mesh will pick up the change and will apply it instantly. So let's come back to the application web monitoring. We can now see how the change to the traffic policy results in 25% of the request being redirected to version 2 of the application and work as expected. By looking even closer, we can also see how the Kubernetes pods are impacted by the change. Now that we have verified that version 2 is functioning and receives web traffic, let's make another traffic policy change. And this time, redirect all the traffic to version 2 by changing its value to 100 and version 1 to 0. Like in our previous change, the Azure Arc-enabled Kubernetes GitOps config, which listened to the repository, will pick up the change and will apply it instantly. Coming back to the web application monitoring, we can see how version 1 stopped receiving requests and version 2 is picking up all the web traffic while the Kubernetes activity gets updated to reflect the change. The ability to install cluster extensions with Azure Arc-enabled Kubernetes unlock powerful options for developers and DevOps engineers, such as applying GitOps configuration and service mesh topologies on any certified Kubernetes cluster. Let's come back to the Azure Resource Group. In addition to Contoso embracing GitOps processes for achieving full application change lifecycle using Azure Arc, they're also looking to modernize their application data layer. Contoso is also using AKS on Azure Stack HCI as an Azure Arc-enabled Kubernetes cluster. This is their target Kubernetes platform of choice for Azure Arc-enabled SQL Managed Instance. Let's take a look at the cluster extension blade. The Azure Arc-enabled Data Services cluster extension will allow Contoso to deploy data services such as SQL Managed Instance and PostgreSQL on top of any CNCF-certified Kubernetes cluster, enabled with Azure Arc. At this point, I want to invite my friend Jess, a senior program manager on the Azure Arc Data Services team, to show you this in action. Take it away, Jess.
Thanks, Lior. Another capability with GitOps is the ability to deploy both the application and the database at one time. Contoso Books' website is being modernized to be container-driven. The developers love Kubernetes for their stateless apps and can now take advantage of Arc-enabled SQL Managed Instance to package the stateful database in the same deployment. Let's explore this solution. Contoso has an MVC app. They use Entity Framework to help with their database development, although any other ORM framework could be used to accomplish this. In the app, the main function calls createDB if not exists, which initializes an Entity Framework database service context named Bookstore Context. The model is defined here. On this website, Contoso has one DB set called Books. In the books class, we can see the database schema modeled with book information such as the title, release date, and price. When we use Entity Framework, we can define our database schema as a standard object-oriented programming class, just like many other ORM frameworks. We can attribute properties with data annotations, such as the one on the price column, which allows us to tell SQL what data type to define the column as. Once the schema has been created, we can then decide how to handle data. We can check for the existence of data and then choose to do nothing, update it, or create more. In this case, the app will look for books. If it doesn't find any, it will insert the first few records. So up to this point, the app is using common programming practices. Now we'll start to see how, by using Arc-enabled SQL Managed Instance on Kubernetes, it becomes very easy to provision and test the app and database, and eventually deploy to production. In the Publish profile, I can see the app is being published as a container image to contosobooks.azurecr.io. Contoso Books has already built and published the container image to Azure Container Registry, but any other container registry could be used. I can see the images by going to the registry Contoso Books and the repository Demo App. Now, let's check out the deployment. The first step is to create a shared secret between the app and the SQL instance and inject that secret into the app and the instance. This is a great security feature of Kubernetes. Then it's going to provision a SQL Managed Instance using the business critical tier. Note that it has 3 replicas. Then it creates a deployment named Web App, which will pull the image from the registry. The information will then be exposed through this service. Next, let's look at the connection string. The connection string uses the naming convention of instance name -external -svc .namespace.svc, which is used to connect to the service endpoint exposed by SQL Managed Instance when it's deployed on Kubernetes. It's using a DNS name that's native to the Kubernetes cluster, so pod-to-pod naming is predictable. This reduces work because now you don't have to register SQL in DNS. Now, I'm going to start the deployment using kubectl. Here, the process of deploying the web app and the SQL Managed Instance has begun. I can use kubectl to see the deployment happening. Here, I can see multiple db- containers creating. This indicates that there are 3 managed instance pods created, and you'll notice that each is running on a different node. Now let's take a look at the storage. I can see a separate Arc data claim for each replica. This means that there are also 3 copies of the data. This is part of the Arc-enabled SQL Managed Instance business critical tier high availability strategy, and I'll discuss the power of this architecture later. So once our web app and SQL Managed Instance are fully deployed, we can get the endpoints. I'm looking for the web app service external IP. I'm now viewing the Contoso Books website. I can see the books that were initially added. Now, I'm going to start adding more books to the website. I have another program that will insert a new book every second and log information such as what server it connected to and what the server version is. Let's look at the logs to see what's happening once that data is being inserted. Each insert is using the connection and it returns some information to the log. Here, I can see the server name is db-0 and I also see the server version. I can also see those new books listed on the website immediately. We've seen the benefits of the deployment. Let's talk about the operational benefits of using Arc-enabled SQL Managed Instance's business critical tier. Generally, every month Microsoft releases a new version of Arc-enabled SQL Managed Instance with new features and security or bug fixes. I'm going to upgrade this managed instance to the latest version. Normally, a database upgrade would be a time-consuming process that introduces application downtime. However, using Arc-enabled SQL Managed Instance's Business Critical tier can solve that problem for us. Business Critical supports online upgrades, which use that built-in high-availability architecture. This process can be fully or mostly automated. It's up to you to decide. Contoso Books is excited to take advantage of this feature because they'll get new features faster than if they used traditional SQL Server on-premises, and they don't need to dedicate resources to time-intensive major SQL upgrades every few years. When I look at this managed instance spec, I see the running version is 1.4.1, which is not the latest. I want to upgrade to 1.5.0. I can start an upgrade using the kubectl patch command. This patch command allows you to change running configurations immediately. Now, by going back to the logs, I can see the app continues to insert books. During this upgrade, I can see that one pod at a time is terminated and brought back up. And I can observe the logs of the inserts to watch the connections. Notice that before the failover, we were connecting to server name db-0. Afterwards, we're connecting to db-1. I talked earlier about the architecture of SQL Managed Instance Business Critical. This was deployed with 3 replicas, which are on 3 different nodes, and each is attached to a different volume. If one of the pods goes down, or a node on which a pod is running goes down, the failure will be automatically detected. If the pod that went down was the primary, such as db-0 during the upgrade, a new replica will be selected as primary, as db-1 was, and the database external service endpoint will be updated to point to the new primary pod. The application doesn't need to be aware of that. It always connects to the DB external SVC endpoint, which we saw in the connection string earlier. Then a new pod will be provisioned and it becomes a secondary. By using Arc-enabled SQL Managed Instance Business Critical tier, Contoso Books is able to modernize their data estate along with their web app and take advantage of Azure's Platform as a Service, high availability, and evergreen upgrade features. What's next for Contoso Books? The business and website is doing so well that Contoso Books has decided to create an app to let the customer enter a store, choose a book, and purchase it without any employee interaction. How? The Contoso bookstore has many cameras deployed to capture which customers pick up which books. They're going to use Azure Arc-enabled machine learning to train and create a model to identify books picked up by the customer by the covers. Customers can purchase the book using the checkout app and walk out of the store with their new book. Contoso can use Azure Machine Learning to train a model to recognize the book cover. So the input of the model is the image captured by the camera, and the output is the label of the book cover. So this is the Azure Machine Learning workspace. If we go to the compute page and look at attached compute, we can find the Kubernetes cluster has been attached to this machine learning workspace. So now I can start my model training work. Let's look at the Jupyter Notebook Contoso created. They use PyTorch to train a 2-node distributed image classification job. Import Azure Machine Learning Python SDK, and initialize the Azure Machine Learning workspace. Then create an experiment named PyTorch Distributed Training. It will use Azure Machine Learning Curated Environment PyTorch 1.6 as the Docker image to host the training job. The training data is saved in on-premises HDFS. It uses the Azure Machine Learning HDFS connector to allow the training script access to the data. Here, I specify the HDFS dataset. In order to run a distributed PyTorch job, I specify Azure Machine Learning PyTorch configuration as the job's distributed backend and the node count as 2 nodes. The compute target name is my attached Kubernetes compute. I specify the job command, src code, and environment, then pass these configurations to the script run config constructor. To save time, I ask the training job to only run 5 epochs. We can submit the job now. When we go to the job detail page, the job is starting to prepare the environment. After only 8 minutes, the job completed. Let me go to metrics to check my job performance, accuracy, and loss. Since the job only ran for 5 epochs, the performance hasn't reached the best. If we run more epochs, the performance would be better. Now let's go to output and logs, where we can find the logs of the job and the PyTorch trained model in the output folder. After we get the trained model, Contoso can deploy the model to the cluster and get an inference endpoint. The bookstore checkout application calls the endpoint URL to get the book cover recognition result. Now we'll register the model to Azure Machine Learning, then deploy the model to the cluster. After the registration, go to Models, find the PyTorch model, and then deploy it to a real-time endpoint. Give an input name as book recognition, choose the compute type as Kubernetes, then select our attached Kubernetes compute. We use the registered model, use the deployment name, select the scoring script, and the Docker image to host the model. I will enable auto scale out of my deployment instance, so the instance will scale out and in according to the traffic. I set the minimal instance to 1 and the maximum to 3. Give 100% of traffic to the deployment and then created. After a while, the endpoint and the deployment are both created successfully. The bookstore checkout application can call the endpoint URL to get the book cover recognition result now. For a quick test, we can go to the Test tab, give example input data, and get the results. If Contoso wanted to monitor the endpoint usage, we can go to the endpoint resource in the Azure portal to find the request latency and count. If we want to see deployment CPU or memory usage, we can also find them in the deployment metrics. Now we've seen how Contoso Books is using Azure Arc to modernize their data estate and using machine learning to further enable customers with multi-cloud and edge analytics capabilities. Back to you, Travis.
Thank you, Jess, for showing us those cool demos. I hope you all found those demos useful to you in how you architect your future apps. Azure Arc is here to help you achieve the right balance. You need agility for faster time to market, but you will benefit from centrally managed governance and security practices and be able to run your app and manage data, your strategic assets, anywhere you need. So what's coming up next? We continue to work on the open source PostgreSQL offering on Arc and hope to bring that to GA soon. Similarly, we expect to bring Azure Arc-enabled machine learning to be generally available this summer. Kubernetes lifecycle management for AKS HCI with Windows Server, together with Azure policy on Microsoft Defender, will also hit general availability soon. With that, let's wrap up our conversation today. Please try the business critical tier and let us know what you think. We've updated our documentation and we continue to develop new MS Learn modules so you can learn at your own pace. Besides that, Azure Arc Jumpstart is a great place to help you quickly deploy the various Azure Arc services for various use cases. If you're interested to know more about the new innovations on cloud-native apps, please check out the breakout session number 11 on this very topic. Thank you for joining us today. We're really excited to see what you built.